Hi everyone, in this lecture we will update the web client and add OAuth and OpenID Connect protocol capabilities to that. In Spring Security, an OAuth compliant client can be created by just including Spring Boot Starter Oauth2 client dependency and adding Spring Security Oauth2 client configuration property. Here you see an example definition. As you see, we set the key-clonk ID and script, also the authorization grant type, redirect URI, scope as OpenID, and finally the issuer URI of key-cloak server. Spring Security 5 automatically configures an OAuth2 client by only specifying the issuer URI value. As we will see shortly, configuring a web client with OAuth2 is simple by just applying OAuth2 configuration, and after doing that, all web requests will be sent by adding the access token automatically. And if there is no access token found in the context, an authorization grant flow is initiated. So let's continue with the details. First, I will add Spring Boot Starter Oauth2 client dependency to the Elasticquery Web Client module, which is our web client. Note that we removed the starter security as it is not needed anymore with this change. Then update the web client configuration file in config server repository with the Spring Security Oauth2 client configuration property. We will set key-cloak client ID and secret, authorization grant type, redirect URI, and scope. And in the provider key-cloak section, we set issuer URI. We can actually encrypt this secret key using the Spring command line and JCE. Let's do that and replace the client secret with the encrypted version. We then need to make a small change on the header and index timeleft templates and change the authentication principal username to full name, as this property will be changed with the OAuth protocol. Then we will change web security config. First, remove enable web security annotation and remove the injected user config data. I will then inject client registration repository and add a log variable here, and then add a method called OIDC logout success handler. This method will return OIDC client initiated logout success handler, and we will create it by passing the client registration repository and then set post logout success URI, which will be one of the correct redirect URIs that we entered on key-cloak admin console. Let's create a config variable for this. We will use this method to configure a logout success handler shortly. I will use value annotation and include the configuration variable we defined in the Elasticquery web YAML file, and then replace the logout URL with this configuration variable. Let's remove this configure method and password encoder, as we will not use in-memory authentication anymore. Alright, let's now change the configure methods. I will delete the HTTP basic first, and then start with authorize request and permit all for the base path by adding a single / with ant matchers. Then for any request we will apply full authentication and then configure logout by setting the logout success handler we just created. Then set this is an OAuth2 client and also specify the OAuth2 login, which will imply OpenID. We can also use userinfo endpoint and customize granted authorities with a custom mapper. Let's do that, although we won't apply authorization here in the client. This will allow us to map authorities to Spring Security authorities, so we can use it in case we need to do authorization logic here in the client also. So let's apply user authorities mapper with a method, and here in the method create a set, and for each authority in JWT, if we get OIDC user authority, extract the ID token, log the preferred username, and then get userinfo. And use the groups claim that we defined as mapper on the key-cloak admin console to map each group to a role using simple granted authority, and update our initial mapped authorities with this list. This way, to authenticate as user, we'll have all the groups as mapped to role_authorities in Spring context. Then open web client config, and in the web client folder bin, pass client registration repository and OAuth2 authorized client repository as injected parameters. We can then create a servlet OAuth2 authorized client exchange filter function instance with this client registration repository and the OAuth2 authorized client repository, and then set default OAuth2 authorized client to true, so that access token will be added to each request automatically. I will also set default client registration ID as key-cloak here, as we use key-cloak as the client registration. I will create a config variable for this one, and use value annotation to replace it. Then we remove the basic authentication, then in the builder we will simply apply OAuth2 configuration to add OAuth2 to the web client. And actually that's it, we don't need to do any change to the service implementation. With just configuration changes, access token will be added to each request that is done from web client resource server. And since we enable Oauth2 login, we will now be redirected to Keycloak server to authenticate ourselves to be able to reach to protected pages. Let's commit and push config server changes now, then run Elastic Cluster, config server and the query service. Note that web client configured to run with a load balancer and uses 8183 and 8185 for that, so let's remove one of the instances for now by overriding the config server properties in web client's application YAML, as here we are running only a single instance of Elastic Query Service. We will run a complete example at the end of this section when we run everything inside Docker. And then run this web client now in the backlog level and try to log in. As you see, we are redirected to Keycloak server, and if we enter correct credentials, we are logged into our web client. Let's check the logs to examine this flow. As you see, we have the initial redirect to Keycloak, where we send some information like code, redirect URI, client ID, and then code return to the redirect URI in the client. Then in the client, we make a post call by sending the code as well as sending the client ID and the script. And here the secret is only base64 encoded by default, so it's actually important to use SSL TLS enabled communication between client and server to be sure we are safe enough. After getting the access token and ID token, here we also see that we make a call to user info endpoint by sending the ID token to get user information. And here we see the granted authorities. As you see, we get the scopes defined for the user logged in. We also see the group's username audience for the ID token and the mapped granted authority roll-up user group, which comes with the custom mapper we defined actually. Finally, it returns to the original URI, which is home, to show our home template. At this point, if we send query to query service, we should be able to see the document for the text test. As with text test, it will return only document 1, and the user that we use to log into the system, app user, has rights to see the document with ID 1. But for other text, we will get access denied. At this point, let's improve this error message a bit. I will update the handle methods in the Elastic Query Web Client error handler that takes runtime exception, and for the error message I will say couldn't get response and mention the message that comes with the runtime exception instead of printing bad request. And if I log out now, great, logout also works, and then log in with super user for example, I can now search everything we want. That's great, we completed the web client. In the next lecture we will add a second web client and see how Keycloak enables single sign-on for two clients that are sharing the same realm. Alright, I will see you in the next section.